Okay, welcome to this next video, guys. Today we're going to be talking about surveying and sampling. Okay, now learning goal for this one here is that students can explain issues related to the collection of data. Now, in the Grade 8 Australian Curriculum Achievement Standards, that's one of the main sort of thrusts with their statistical analysis stuff that they want you to look at, is that idea of, can you understand and comprehend when data has been taken incorrectly, when bias is being used, when people are trying to say particular things rather than letting the data speak for itself. So that's a really important one for you to get your head around. And for the assessment item, it's probably going to be the big difference between people who do really well and people who sort of just manage to be able to pass the assessment on them. Okay, so this is sort of a really good one for you to get a handle on, and should give you some good ideas of where to go for your assignment. Okay. So by the end of this, you should be able to make judgments on the validity of a data set, analyse the shape of a histogram, predict the effect of outliers on the mean and median of a data set. Okay, so something you might have heard of before is something called the bell curve. And I'm going to try my hardest to do a drawing of it. Oh dear. So let's just say, here's our axis, and we've got an axis here. It doesn't always have to be one up here. We're going to do it anyway. Just maybe help me out. It's called a bell curve because it gets like a nice sort of bell shape like this. So it's a graph, it's a function, and what it sort of says is, let's just say, well, I might redraw it, get rid of this line in the middle, and we'll just go with. Yeah, this will make life easier for myself. Okay, so we're just going to go for this one, and we'll make it like this. And let's say that this is height of people. Okay, which is a pretty typical one to have a bell curve for in a normal population. So let's just say this is height. Oops, sorry, this should be number of people, and this is their height in centimeters. Okay, now, so what you're going to expect is that a lot of people will have an average amount of height. Okay, this is sort of our average area in the middle here. So we're going to expect a lot of people to have an average height, and as we get out to people who would be considered tall and people who would be considered short, you're going to get less and less people as we go along, less and less people as we go along. Now, if it's a nice, what's called a normalized normal distribution, okay, it's sort of nice and symmetrical, okay, everything's, you can cut it in half, this side's sort of the same as this side, and what that means is that we got about, I think off the top of my head, it's roughly 60% of people are in this kind of middle chunk here, okay? And so that leaves another 20% out this way, out either direction, okay? And so that's sort of how it works with our bell curves, okay? Which kind of makes sense. 60% of people are sort of average height, okay? Right. So that's what our bell curves mean, and they turn up in survey data, things to do with nature a lot, okay, in the biological sciences especially. Okay, so we're going to have a bit more of a look at that, and surveying as well. Okay, so there's certain factors that can affect the outcome and validity of a survey, okay? So let's say, for instance, one of the first issues that we can come up against is this issue of sample size. Okay, so let's say, for instance, I asked in our class, how many times a week would you watch the show Pretty Little Liars? And I made, let's just say, the average amount was sort of 100 times a week. Now, our class is only about 25 people. So you would probably say, well, I couldn't just say then, well, the average person watches Pretty Little Liars 100 times a week, because that wouldn't be indicative of the whole population. Everyone else I'm only surveying 25 people, whereas the rest of the population is a huge amount. So we need to be careful when we're surveying that our sample size is large enough. Okay, so obviously a larger sample is going to give us better data. Okay, or more to the point, more trustworthy. Okay, so the more people that you sample, the more people that you survey, the more trustworthy, the better in a scientific point of view your data is going to be. Okay, representative bias. So this is an important one as well. So let's keep going with my idea of surveying the class about how many times you watch Pretty Little Liars a week, and I figured out that the average amount of times, as I said before, was 100 times a week. Okay, now with this representative bias, I'm only asking, not only have I had an issue with the size of the sample I've taken, but there's also an issue with the type of people that I've asked. So I've particularly asked a small subset of people. So small subset of teens who I know particularly like the show. Okay, so that's going to give me a representative bias. Same as if I went and asked, I went over to the retirement village near school and asked them how many times a week they watch Pretty Little Liars. You would get a representative bias in the opposite direction. You'd probably get 0 times a week. Okay, and again, that wouldn't be indicative of the entire population either. So you need to be careful about who has been asked in the survey. Right, again, data error. So this is a simple one, and you've probably seen this in your ABS data that you took off the internet for your assignment, that some people's height was recorded as like 25 centimeters. Okay, now that's probably an error. Okay, I don't think there's a lot of 13-year-olds in Australia that would be 25 centimeters. So what's probably happened is that they've accidentally entered in 25 rather than 125. Okay, and this creates an outlier that can affect your mean and your other statistical analysis. Okay, right. So our data can also be displayed as a histogram. Okay, and so as I said before, let's get our so we can display our data as a histogram. Some of you might have already been doing this in your books, but if we have, you can make little, like the columns of stuff. Histograms are supposed to be touching actually. So let's pretend that it's like this. Something like that. And you can kind of tell that, you could sort of draw one of those curvy kind of things across the top of this, sort of fit it through, and it's going to help you look at your data. Okay, so let's just say that this could again be our number of people, and this could be our height still. Okay, so you can represent our data as a histogram like that. Now, this is really one of the important ones for us to think about, is that a histogram's skewness. Now, it's an important term, it's a technical term, and it's a good one for you to be able to use in your assignments and in your explanations, evaluations, justification, that kind of stuff. Okay, so histogram skewness can tell you a lot about the nature of a data set. Okay, now, so let me help you understand what these drawings are sort of saying. You can maybe see this dotted line in here. Okay, so this part here, that would be a normal distribution, like I was showing you before. It's nice and symmetrical. However, the red line is the actual data set that we're looking at. And as you can see, this side here follows the bell curve, whereas over here, this side comes way out here. And so what's happened is that out here, there are some of those things called outliers. Okay, so they're data points that lie outside sort of the normal area, the bulk of the rest of the stuff, okay? And what this is going to do typically, now not all the time, is so our median is going to be kind of so here's our mode. The median's going to be right around here, typically, but what the outlier does is that an outlier will drag the mean away towards it, okay? So these lower outliers are going to drag the mean negatively away from the median, so that's why it's called negative skew, okay? Now I'm sure that you can see with this one here, if round about here-ish is our median, the presence of the outliers out here are going to drag the mean. It's not always a huge amount, but it's going to drag the mean a little bit this way, positively away from the median, which is why this shape of one is called a positive skew. Okay, so as you can see, that's why there's this discrepancy sometimes between the means and the medians, is because of outlying data points. Okay, now that idea of skewness is very important for you to get your head around as far as evaluating your statistical analysis in your exams and assignments and things. So please get your head around that. Make sure you're having a go at some of the textbook questions that are on that idea of analyzing the validity of a data set. Okay? I hope you enjoyed that video, and please come and see me if you have any issues. Thanks.